we have Dylan Fox, the Director of Operations for XR Access, who will be discussing how to improve accessibility in XR. And we are so excited for this session. This is something that, as we've said before, has come up at pretty much every event we've gone to this past year, this question of how can we make these experiences more accessible for all of our students. It came up just now in our fireside chat with Meta. And so we're really, really lucky to have Dylan with us, who's going to be sharing some really concrete tips on how we can do this. So before turning it over to him, I will just introduce him. Dylan Fox is the Director of Operations for XR Access, a research initiative of Cornell Tech. An expert on accessibility for emerging technologies, he advises groups such as Meta, the W3C, and the FCC on how virtual and augmented reality can be more inclusive. He chairs the annual XR Access Symposium, co-founded the Accessibility in the Metaverse Working Group of the Metaverse Standards Forum, and is responsible for many ongoing initiatives to connect disability advocates, technologists, academics, and other key stakeholders to solve difficult problems in accessibility. Like I said, we're already getting a lot of questions about this throughout the conference, so I'm sure many will come up during Dylan's session. Feel free to just drop them in the chat. We will have time for Q&A at the end, so we'll spend some time talking about that. And Dylan, I will hand it over to you.
All right, thanks so much. Really excited to be here. This is a fantastic chance to learn all about kind of the education and training things in the metaverse happening. Today we're talking about breaking barriers, some cutting edge techniques for improved XR accessibility. Like you said, I'm Dylan Fox. You can feel free to reach out to me at dylan@xraccess.org. And I'll be putting more info and resources at the end of the presentation. But what we're talking about today, first, I just want to take a moment to define what we mean by accessibility, because it's something that has become a bit of an overloaded term lately. Then we're going to spend most of the talk talking about new techniques for accessibility in XR. And then I'll share some resources and hopefully we'll have some time for Q&A. So starting off, defining accessibility, there's three key words that come into this conversation: accessibility, impairment, and disability. And they're all related to each other, but differences between them are really telling. So accessibility means that something is usable regardless of ability. And abilities come in all shapes and forms, right? Being able to see, to hear, to move freely, to process information. And they come on a spectrum, right? You may be a little bit short-sighted, or you may be Legolas and able to spot the eyes on a flea, 100 miles off. But everybody has different abilities. An impairment, meanwhile, is something that hampers our abilities. So your vision, for example, might be impaired because you lost an eye in a sword fight, or it could be because someone turned out the lights. And impairments aren't on their own a problem necessarily, right? If somebody turned out the lights because it's bedtime, that's not a problem. Your vision is impaired, but you're not worried about it because that's the time and place for your vision to be impaired is at night when you're going to sleep. So disability, and specifically the social model of disability, is then talking about the mismatch between ability and expectation, right? So somebody using a wheelchair may be impaired for most of the time, but they're not disabled unless the only way into a building is through some stairs. And so with that in mind, when we talk about who is accessibility for, I think there's a lot of misconception that, accessibility is for somebody, say, like this, right? This is Paralympian Ma Lin of Australia, who's a gold medalist Paralympic champion, lost his right arm at a young age, supposedly when he stuck it in a bear's cage at a zoo. So listen to your mother when they tell you that. But what a lot of people think about accessibility, they think about people like Lynn, those who have permanent disabilities, permanent impairments, I should say. But the truth is that impairment comes in all forms, and that includes temporary impairments and situational impairments. So, you may not have use of your arm because it was bitten off by a bear, or you may not have use of it because it's in a sling or because it's holding your child, right? And the point I'm trying to make here is that accessibility affects everyone, right? And these same accessibility features that are useful for the people who have lost their arm for any number of different reasons, whether it's permanent, temporary, or situational, that accessibility feature is going to apply to all of them. It's something we call the curb cut effect. Those curb cuts and sidewalks, they help people who have wheelchairs, but they also help people who have baby strollers or bicycles or any number of things. So I just wanted to put that out there because a lot of the time, when I talk about accessibility, people think, oh, well, we don't really have the time and capacity to put in all this effort on accessibility features that are only going to help, some small portion of the population. And that's not really right. When you do these things, they help everybody, including yourself. You're designing for yourself at a future time, whether you know it or not. Uh, so, with that out of the way, let's go ahead and shift our focus to XR specifically. So I'm going to go over a couple of things here that are kind of on the bleeding edge. There's much, much, much more than this because it turns out trying to make a completely new form of media and interaction accessible for everybody is a little bit more than can be squeezed into 30 minutes. But I'm going to talk about some of the new and interesting ones. And if anybody wants resources or has questions, definitely feel free to reach out. And we've got a ton more where this came from. So first up, many of you are probably familiar with the idea of screen readers. So a screen reader is a tool to basically take all of the information on a page, and specifically visual information, and turn it into a kind of one-dimensional string of words, right? So here you see we have an Excel sheet up, and the screen reader is reading out these cells one at a time. And you can tell already that this is kind of gets a little bit tricky when you have this two-dimensional information like an Excel sheet. It gets much trickier when you're trying to apply a screen reader to 3 dimensions. And so that is where tools like scene weaving come in. So scene weaving is, the full title is Scene Weaving, an interactional metaphor to enable blind users experience in 3D virtual environments. This is something that was published in 2023 out of Microsoft Research in combination with several universities. And we had a great seminar about it last year. And the fundamental idea here is that a screen reader alone is not sufficient to navigate a virtual environment if you're fully blind, right? Trying to take everything in a 3D scene, everything that's all around you, everything that might be happening, and just condense it into a line of text, there's a bit that gets lost in translation there. And so what's really awesome about the screen reader prototype is that it's a mix of kind of top-down and bottom-up design to enable exploration, navigation, and social interaction in VR spaces, even for people that have no vision at all. And the way it works is effectively, it's a number of different tools all combined. So for exploration, let's say you're trying to understand what's in a space around you and where you are in the space. There's things like echolocation, where you can tap your foot to the ground or listen to your footsteps as you walk and get audio feedback from the room, understanding, oh, I'm near a wall because I can hear the echoes coming off right next to me. Versus I'm in a small space, I'm in a large space. It's one of the tools that blind people use every day to understand the spaces around them. There's things like announcing nearby objects where you can kind of send out this circle, this aura, and as things enter that radius, they read off and it tells you where it is. And spatial sound will tell you what direction it is as well. And there's things like gaze mode, where anywhere you direct your gaze, it tells you what is in your cone of vision and how far away it is, so that you can look around a space and build up an understanding of where things are. In terms of navigation, it also has that top-down factor where if you've used a screen reader, you'll know that it doesn't just read out everything in a page one and one after the other. What it'll often do is use a tree, right? It'll have a header tree effectively, where it'll read off the headers, and then you can kind of decide to go into one of those, and it'll read off the subheadings, things like that. You can kind of apply that to VR as well, right? In this case, you look at the upper right image here, you can see they have a list of things in this space. And so rather than trying to kind of use those exploration tools to hunt down the interactable objects, you could just proceed through a list and it'll tell you what it is, it'll point you towards where it is, and it'll give you options for interacting with it, including the option to just teleport straight to it. So being able to do that, there's still a lot of questions around, okay, if you have multiple different rooms, you have to navigate to a big room. There's a lot of questions if we were to put this into a fully fledged system and not just a prototype. But this type of approach that's really flexible and that enables people to explore in the way they want to and that suits their goals at the time, that's really valuable. And then finally, the social aspects. The ones they experimented with here are things like notifications, where if somebody approaches you, it'll pop up something, even if you're in the middle of something else, to let you know, hey, somebody's next to you, they want to talk, and it'll automatically orient your character to face theirs if you say yes. There's a lot more you can do in social spaces as well. We've been working at Cornell on some interesting work on nonverbal descriptions of what other people are doing. So being able to understand things like somebody's making eye contact with you, or if somebody does movement or facial expressions, you could receive some type of haptic or sound cue to know that. Very much a space that is still ripe for exploration. But this is, I think, if we were going to look towards the future and see a VR setup that really is accessible to everybody, I think this type of tool is something that would really want to be built in to make it accessible to blind and low vision folks. Another tool for blind and low vision folks is the idea of sighted guides. So many blind people, when they're in a new environment, will ask for a sighted guide, which is a human that can help guide them around and answer questions about the environment. Right. And usually the way you do that is, there's a lot of etiquette around this. I'd encourage everyone to take a look if you're not familiar with it. But the guide will offer usually an elbow, and the blind person will hold on to that gently and walk along. A lot of blind folks don't like it when you just like grab their hand and try to like pull them somewhere. Um, it's not the way it's done. So with sighted guides, it's this relationship between the human and the guide that helps the blind person explore the environment more easily. And there's no reason that can't be done in virtual reality. Um, it's tricky right now because most avatars, for obvious reasons, can't interact with each other physically. So there's no way in any of the current social environments, for one avatar to kind of tow along another avatar. But there's nothing stopping us from doing something like that. And so one of the things we're researching at Cornell right now is sighted guides, both in the form of human guides as well as AI guides that could function as almost like a seeing eye dog and lead somebody around an environment that they themselves can't directly observe. You can see overlap of that with augmented reality as well, with tools like Be My AI, which is a tool from Be My Eyes that lets blind and low vision folks use machine vision and large language models to ask questions to a computer about their environment. And then there's also things like this Glidance guide robot and wayfinding AI from Glidance, I guess. Glidance's guide robot that is, at least in theory, I haven't had the chance to try this one out myself. Again, applying machine vision and a lot of those other modern technologies to guiding somebody around an environment as this kind of personalized tool. There's a lot of stuff like this that purports to take the place of white cane. I've heard mixed reviews about a lot of them, but as we move forward, I think we'll keep finding tech that works better and better for people in their own environments and needs. Okay, moving forward from blindness and visual impairment to hearing, one of the big things with regards to hearing impairments and deafness is subtitles. Subtitles are incredibly useful for everybody, not just for deaf folks. They're great for people who want to turn the volume down. They're great for people who are maybe learning English as a second language, or who have different types of verbal processing challenges. And yet, a lot of the time, you see people just trying to kind of apply subtitles from 2D straight to 3D without really thinking about what has to change when you move into 3D. So what we're looking at here is a piece from Cosmonius High from Alchemy Studios, which is a very fun game. You're an alien on your first day in high school. I encourage folks to check it out. And Alchemy has been a really great group in terms of pushing the envelope on accessibility over the last several years of virtual reality, all the way back to Job Simulator on the Vive back in the pre-order days. And at our last symposium, they gave a whole talk on the design of their subtitle system. And that includes, in the GIF here, you see the size of the subtitle adjusting based on distance, so that appears as a constant size to the user. But you also want subtitles to be placed at the depth of the speaker, to follow the player's vision, but loosely, not like one-to-one, using opacity to convey depth and avoid some of these conflicts that comes when you're trying to read a subtitle and then something passes in between you and the camera. There's a lot of nuance that can go into this. And so I think taking a look at that video and some of the other resources we do have some open source plugins for Unity on our XR Access GitHub that are really helpful for this as well, although I don't know that they've updated to quite the level of polish that Alchemy has. But this is the type of thing that if you really want to have an accessible experience, you want to do subtitles correctly, because just trying to throw a bunch of subtitles on the bottom with no indication of who they go to and versions conflicts that could be causing nausea is not going to get you an equitable experience for the people using those. There's also some really interesting research going on right now in terms of haptics. We have tools like the Haptics gloves that are steadily coming down in price and are able to not only give you force feedback on your fingers, but also stop your fingers in motion so that when you say hold on to an apple, you can really feel the apple in your hand, right? And that is an amazing tool for somebody who is, deaf blind, for example, or really for anybody that wants to use their sense of touch as an additional means of understanding the virtual environment. Because what you'll find often in accessibility is that modularity is really vital. If somebody is going to want to experience the world using their eyes, somebody else is going to use their ears, somebody else is going to use their hands. The people who want to use their nose, their tongue might be disappointed for a little while, but in terms of providing more options to your users and providing a more immersive experience, that is good in both of the kind of visceral feel of the environment as well as in letting people use the techniques they're used to. So considering using some type of haptics to allow that sense of touch to come into play is going to really help to make your experience more accessible. The other one we've got on this slide is a research paper called Stretch or Vibrate, Rendering Spatial Information of Static and Moving Objects in VR via Haptic Feedback for Blind People by Jixing Li et al., University of Maryland in 2024. I pulled this up because I think it's a really interesting example of some of the exploration that's happening in academia right now. What this is they experimented with having somebody kind of put their hand underneath this device. And what the device could do is put a little kind of nub down at the center of the back of their hand and then move it in any direction, either dragging it across their hand or kind of vibrating up and down. And they use this to indicate the motion of moving objects. And people could really kind of understand, where the object is around them based on this type of haptic feedback. And right now this is still something that uses a big stationary thing in a lab somewhere. But this is the type of research that we could absolutely see being implemented into things like the haptics gloves or whatever the next generation of haptic feedback devices is as time goes on. So keeping an eye on academia and all of the research that's happening there is really important if you want to stay ahead of the curve on this, because there is a lot of things being thought of and experimented with in academia way, way before anybody in industry is doing it. I just want to talk a little bit about brain-computer interfaces, just to put this on people's radar. This is something that is really promising for people that can't use kind of any of the above. And the examples you got here are Cognition's Cognition One brain-computer interface. This is a device that uses primarily input as well as brain-computer interface to help folks that have really severe motor disabilities who may be able to only move their eyes or not move anything at all, communicate with others and interact with the internet, with objects around them and all kinds of things. And to me stands out as an example of technology that is drastically improving the quality of life for some of those people that have really severe disabilities. The other one is Meta's Surface Electromyography SEMG wrist controller. And this is a really fascinating piece. Hopefully we'll see it, I think, commercially out of Meta soon. But it can, since it uses the signal sent to the hand rather than the hand itself, it can even detect when somebody who doesn't have a hand is pinching, right? And so tools like that can enable people with limb differences or other challenges with actively holding controllers are really, I think, going to be important as we move forward in making sure this stuff is equitable, as well as making it better for everybody by letting you have just a nice little wrist wrap instead of a whole wonky set of controllers that you have to lug around. And then finally, since we don't have some time for Q&A, I just want to talk a little bit about self-representation. Now, there's a lot of thought that goes into avatar creation these days in terms of we've seen a lot of growth in things like letting you use things like hearing aids or a wheelchair. But some of the interesting research at Cornell right now is on self-presentation preferences of people with invisible disabilities through embodied social VR avatars. This is things like floating med reminders, giant spoons to represent spoon theory, zebra print to represent rare diseases, because you've heard the phrase you hear if you hear hoof prints, think of horses, not zebras. But for sometimes it is zebras. With people with rare diseases, the zebra has come to be a bit of a symbol. And this includes things as well like stealth mode, right? There's a quote from one of the participants saying, if I'm in a VR space and I just want to enjoy myself and I don't want anyone coming up to me, I should be able to say that. But if you think about the other users of the space, you really want an invisible person watching you. So maybe rather than being invisible, I can just make my avatar more translucent instead. Just don't come to me. My avatar is not really colorful right now, right? So things like that, being able to let neurodiverse people and everybody else represent themselves through their avatar, both in terms of how they want to be represented in general and in terms of those moment to moment emotional states. Being able to put on something on your avatar that says, please don't approach me right now, or I'm open to conversation, communicating that through ways other than just typing it in text or something is really helpful. And finally, I want to call out that there is still a lot of ableism out there, especially in social VR right now. There's a quote from one of the participants from the study who is diagnosed with ADHD and autism. It says, "I don't go out of my way all the time in VR to disclose my disability. I don't want to get labeled that way. I don't want to be labeled as someone who's, R word." That word's been thrown around a lot recently. And so I just want to use that to remind everybody that these solutions are helpful, but none of this can be solved purely with technology. If we really want to make XR as a whole more accessible, yes, we need platform owners and content creators to implement this types of accessibility into their technologies, but we also need teachers and students and everybody else to understand what attitudes they hold might be either advertently or inadvertently ableist, and address those and make sure that we're creating an environment where people can feel comfortable to disclose this type of thing about themselves. So that was the whirlwind tour. For folks that are interested in this, definitely check out our XR accessibility project. This is a kind of one-stop shop of resources that we've been cultivating. So you can find that at xraccess.org/GitHub. And definitely feel free to reach out to me. And you can go on our website, XR Access. You can email me. I put my LinkedIn up here if anybody wants to connect. We are really actively exploring the education space right now and potentially looking for partners to, apply for grants on making educational technology in the XR space more accessible. So don't hesitate to reach out, and thanks for your time.
Thank you, Dylan. That was truly a fantastic presentation. I really loved all the examples that you gave throughout of like different techniques that we can be using to make these experiences more accessible. We do have like 3 or 4 minutes now, so if anyone has questions or comments, feel free to drop them in the Q&A or the chat and we can moderate them. But I'll kick us off. I actually have a question for you, Dylan, because this is something that I've seen come up like working with students in classrooms. There's kind of 2 components, right? It's the platforms sometimes aren't the most accessible, like the app itself, but also then the headsets and the devices, right? And so I'm thinking from like a developer perspective, you may have a developer that builds an app that, is great in terms of accessibility, but they're still limited by the fact that, it's being deployed on the VR headset. So I'm just curious if you have any thoughts about that, if you feel like there are some headsets that are better in terms of accessibility than others, and anything you can share around that.
Yeah, absolutely. It's true. There's definitely kind of a bottleneck here where if the platform isn't accessible, then the efforts of the content creator don't matter as much. I think in terms of which headsets are the most accessible, the off the top of my head, I would really want to praise the Apple Vision Pro for bringing in kind of on launch day all of the accessibility features of iOS, right? Anything you can find on iOS, a lot of especially blind and low vision people will use iPhones for their screen readers, things like that. All of those were baked into XR, and they did some good thinking about how to make them work. They had features like, oh, do you want to use gaze? Do you want to use head motion? Do you want to
Mm-hmm.
use finger or wrist pointing that make it a lot more flexible and modular? Unfortunately, the price point is not the
That's
most
what I said. The
accessible.
price point is, but
Yeah,
I
yeah,
was I was really excited. I didn't know about that tool that you had in your slides, the Meta Wrist controller. I think that's a really, really exciting tool. We
absolutely. And I
did
was
have,
at, oh, sorry, go
go
ahead.
ahead. No, no, you go ahead.
I was gonna say we were at did last year as part of a co-design with Meta where we had a bunch of folks with quadriplegia come in and we were doing some design thinking. Obviously I have no idea what whether what they'll do with it, but it was a really exciting time, and I will definitely say this can be made to work with folks with all kinds of different disabilities. It's just a matter of whether we have the will to do it.
Mhm. We had a
I would
question. Go
I
ahead.
was I was just going to add real quick. We also do recommend that you have desktop or mobile versions of your XR software, and that those work with regular keyboards and other kind of current accessibility tools. Because
Mhm.
anything where you have to get every single person into a headset, it's going to be a lot harder to make that happen.
Yeah, no, of course. And that's been kind of our approach at Immerse is, we have our desktop app and we have our VR, which definitely has helped a ton just in my experience when we're working with different students. Some just still at this point prefer to be on a computer. We had a question come in saying, curious what kind of features are being developed to help with hand tremors. My father with Parkinson's is excited about VR, but struggles heavily with handheld controllers. Do you have any
Mm.
insights on that?
Yeah, yeah. There's a great tool called the Walk-in VR Driver. Um, you can find it on our GitHub, and I'll maybe we can put the GitHub in chat. But it is a tool that works with Steam VR and can do things like motion multiplication. So, for example, if you have tremors, then you can take large movements and do them as small movements, or if you have a limited range of motion, you can do small movements and use those as large movements. Those types of sensitivity features are something that can really help with that, along with better algorithms for object selection and things like that.